We can also use the municipal solid waste, or so-called MSW, to produce ethanol. We've taken a look at that, and you'll see the results shortly. And the reason that's interesting is that we're getting into a landfill situation. We'd like to do something other than bury this stuff, and this turns out to be actually a promising kind of approach. Okay. Now, compressed natural gas. Compressed natural gas is also, as you'll see in the summary slide, a very advantageous approach because you can use the same kind of engines you have now with a little modification for higher compression ratios. You can store the gas, carry it around with you. And in the US, and particularly in Europe, there are plenty of vehicles out there running on natural gas, so we see this. And the benefits of natural gas are manifest, and we'll look at those in a second, okay? So this is kind of a summary page just in words in the right-hand column of what looks promising as far as reducing oil imports. And in addition to abating the CO2 burden on the atmosphere, we're trying to look at what happens with oil imports no matter where it comes from. We don't have enough. And so we see some potential here. You see basically corn ethanol at the top doesn't help us at all with oil imports. We actually need more imported oil to make corn ethanol than otherwise. And then you look through the CNG, the algae approaches in the middle of the table, and then on to the bottom where we have a big potential to reduce imports. Now that's aside from life cycle analysis, but it's another factor that we need to think about. Okay, now I'm at the first summary table that I want to spend a bit more time on. So this is basically thousands of computer runs distilled into two tables. And let's try to understand this. Along the left-hand column are the kinds of fuels that I've been alluding to. Very briefly, but nevertheless, these are the ones that seem like they would be worth looking at. And start over at the right-hand side. We're talking about carbon today. So what we want in that right-hand column is a small number. And this is the life cycle carbon dioxide burden of these fuels. And the life cycle here is 125,000 miles in a modern vehicle. And if we look for the small number in that column, we see CNG, compressed natural gas. That's the CO2. Look at the energy ratio. Now, it's hard to beat gasoline and diesel from that point of view. And remember, this is the energy input divided by the energy output. So only 5% or 8% of the energy that's in gasoline is needed to refine it. So then let's look at the next two columns, working again from the right, and that's water. So with water, we have a situation where the numbers are between per gallon, 5 and 10 gallons of water per gallon of fuel, except for CNG where there's no water required. And algae, of course, we'll see in the next slide, is even better. And then the last thing is land use. And I said that in the biofuels area, that was a problem, which we'll see shortly. But as far as the number of acres we need for CNG plants to meet half the transportation energy needs of this country, it's pretty low. So the consistent overall winner is CNG, if you're going to look at fossil fuels. And remember a couple of these numbers when we go to the next table, if you would. These are the biofuels. So in the top of the table there, we look at the same two reference numbers, which are the current fuels. And again, start with the right-hand column and see where our smallest number is. Well, what's the best one there? Anybody? What do you think? Where's the smallest number? In the rightmost column. Yeah, algae actually absorbs CO2, so if I put a number in there, it would be some negative number. And that's hard to beat. Now, what about the energy ratio? The winner there, except for the conventional fuels, again, is algae, smallest number. What about water use? Well, look at, for example, corn ethanol. Huge numbers up there. Soybean biodiesel is a pretty big number too. But down there with the algae, the water use is a factor of 10 or 100 less than what we have for some of those crop fuels, and we just don't have that much water. You know, I mentioned Mississippi rivers. To do corn ethanol for half the cars in the country would take 10 Colorado rivers, and we simply don't have 10 Colorado rivers of spare water around. We're in a drought out here, and in the central part of the US as well. So algae starts to look pretty good. What about the land use? Well, it's pretty small. You see, to do half the fuel requirement of the United States is about 13 million acres. And if you look at the corn ethanol, it's about 337 million more acres of land than we have available to do that. And you see we're over 100% in the fraction of US cropland. So we got a problem with ethanol. And I should say that LCA is using data that's been around for a long time. All that we've done is basically looked at the bigger picture and tried to draw some conclusions on that big picture basis. Now, if you had been in Congress 10 years ago when they were looking at ethanol, and you saw this table in front of you, would you be voting for an ethanol program like we have in this country?
It would depend on what state you're in.
No, the answer is yes. Because we have other external factors that go into the process. So what I'm trying to say is here, let's introduce a little bit of science into the public discourse. Let's look at what we already know instead of billions of dollars of subsidies for ethanol plants that are now standing idle. We could have done better.